Hello friends, welcome to aimstoday YouTube channel. In this, we are going to see AIMS India live sessions. Here go with chemistry subject. Today, as it is the first day, we are going to discuss about the basics of chemistry. When we discuss about chemistry, the basics come under like matter, language of chemistry, symbols, equations, formulae. These all come under basics of chemistry. So in this, first of all, we are going to discuss about different states of matter. First, what is this matter? What is the nature of this matter? Let us see here. Matter is anything that has mass and occupies space and can be perceived by our senses. Matter exists in many forms. So here we see some different forms of matter. These all we observe in our general life, everyday life around us. Here you can see some examples: a glass, pieces of ice cubes, a mug, ice fruit, volcanoes, stones, metals like gold, even plants, air. These all come under different kinds of matter. As we look at our surroundings, we see a large variety of things with different shapes, sizes, and texture. Here you can see some examples are shown. Milk we drink at morning, and cool drinks like Coke, which we take in summer, and bells in temples and we see, and different colored balloons, parachutes, books, fruits. These all come under different forms of matter. Because as we said, matter is anything which has mass and occupies some space and perceived by our senses is called a matter. These all we can see, and even we can perceive them by our senses, and these all are having some mass, they occupy some space. Hence, these are all called different forms of matter. Everything in the universe is made up of material which scientists have named as matter. So, definitionally we say matter is anything which has mass and perceived by our senses. As we said, the air we breathe, the food we eat, stones, clouds, stars, plants, animals, everything which we feel, which we see, which they occupy mass, which they can be perceived by our senses. These all come under forms of matter. Now, how this matter is classified? As we said, there are different kinds of matter. How can we classify this matter? So, the classification of matter can be done on different characteristics. So, there is a scientific way for the classification of matter. Based upon the scientific classification, matter can be classified based on two main factors. One of them is physical classification and the second one is chemical classification. So here you can see the flow chart for the classification of matter, which explains us how it is classified. So first one is a physical classification. This classification depends upon the arrangement of molecules in the matter. So based upon the arrangement of molecules, matter is classified into 5 types. And the second one, those 5 types we are going to discuss in this session now. So all about solids, liquids, gases, and plasma, BoseEinstein Condensate states we are going to discuss now. And the second classification, that we say chemical classification. This classification is based upon the purity or the chemical composition of matter. Based upon the chemical composition, matter is classified into 2 types. They are pure substances and impure substances. About these pure substances and impure substances, we are going to discuss in the further session. First, let us come back to this physical classification of matter. That means, based upon the arrangement of molecules in the matter, matter is classified into 5 types. They are solids, liquids, gases, plasma state, and Bose-Einstein Condensate. Mostly, frequently we observe in the books about the first 3 states of matter. So these we take as main states of matter, which are observed frequently in our daily life. These 2 are very rare and seen in very few conditions. So first let us go through these 3 states of matter. So here we see physical classification. Matter is composed of extremely small particles. As we said, these particles might be either atoms or molecules. Based upon the arrangement of these particles, matter is mainly divided into three types. Of course, we have seen in the flow chart at 5 states. First, we are going to discuss about the main 3 states of matter. They are solids, liquids, and gases. Here you can see very fine example which we see daily in our homes. Ice cubes which are in the solid form, the drinking water which is in the liquid state, and the vapor state of water that we say steam. These are the 3 states of matter. Let us go through these one by one here. First among them, solids. In solids, molecules are closely packed. Their positions are almost fixed. It means all the molecules are tightly binded one to other. There is no gap between them to say. So because of the tight bindness, they cannot move there and here. Particularly, they will be in one place, they will be having fixed shape. So here we can see some examples for the solids. So the candle, stones, crystals, some tools which we use at home, and vessels, fruits, these all come under solids because in these all molecules are tightly binded. There is no free movement for the molecules. They are rigid, we say. So these all properties you can see as a flow. The properties of solids or the general properties of solids. First we said solids have fixed shape and they have fixed volume too. You can take any example. If you see here there is a fruit we have shown, it is having a fixed shape and even it occupies a fixed volume. So not only this, all the solids are having fixed volume as well as fixed shape for them. And one more property, generally solids cannot be compressed. Take a pen, try to compress it. It can't be compressed because already in these solids are having tightly bindness. There is no gaps between the molecules. So the compression of these solids is a little impossible. They have no gaps between them. That is why they can be said incompressible. A solid does not flow. That means they cannot move themselves until and unless some external force is applied on them. If we take some mobile or duster, if we keep on the bench, it won't move itself unless if we apply some force on that. That means they cannot move in their own. That we say they are rigid, they cannot flow. And next property, a solid expands very little on being heated. If we take a iron piece or some other metallic piece, if you start heating it, even if you heat a long time or with high temperatures, it won't expand much. A little expansion we can observe in the metals or solids because of tight bindness. Solids have very less interparticular spaces and very high interparticular attraction. Here 2 points are there. The first one is interparticular space. As I told, molecules are tightly binded. Between the molecules, the spaces are very less. As there are very small size gaps between them, that we can say intermolecular spaces are very less. Interparticular space is nothing but the space between the two adjacent molecules. That we say intermolecular space. And in the solids, molecules are as they are tightly binded, there are no gaps between them. This intermolecular space is said to be very less or negligible. Whereas the second point in this, interparticular attractions. So there are always some attractions between the molecules of any matter. These attractions we say intermolecular or interparticular attractions. So the attraction existing between the side by side molecules we say interparticular attraction. These attractions will be existing in all the states of matter. But these attractions are very high in case of solids. Because of these high interactions only, these molecules are held together one to other. So these are the general properties of solids. Next we go through the second state of matter, that is liquids. In liquids, the molecules are not packed as close as solids. Of course, in this also molecules are closed a little, but it is not that much of like solids. Here you can see some examples they have shown. Liquids which we see in our daily life, water we drink every time, and the fruit juices, cool drinks, and even we can say some more examples like oils, petrol, diesel, these all come under liquids. So what are the general properties of these liquids? Let us see. First among them, a liquid has no fixed shape. It takes the shape of container. Yes, these liquids, they cannot have any fixed shape for them. If you take a glass of water, that water will take the shape of this container. You pour the same water into a bowl, that will take the shape of the bowl. If you pour this same water into a test tube, then the water will take the shape of that container test tube. In this way, not only water, all the liquids, they do not have any fixed shape for them. Because of loose intermolecular force of attractions, these molecules of liquids, they can slide one another. Because of this reason, liquids do not have any fixed shape for them. A liquid can be compressed only to a small extent. Of course, the extent of compression is a little greater than that of solids, but even in liquids also, compression is less. When you apply high pressure on the liquids, they will be contracted a little. That will be a little greater than that of the solids, but it is less. Liquids can flow. This we know. When you take a glass of water, if you pour the water down, that will flow on the floor from higher altitude to lower altitudes. So this is because, as I told already, between the molecules of liquids, there are some gaps. They are loosely packed a little compared to solids. Because of this loose packing, the molecules of liquids can slide one another. Because of this sliding, the liquid can flow from higher altitudes to lower altitudes. That means liquids can flow. Next property, a liquid expands or contracts more than a solid. If you heat a solid, or if you cool a solid liquid to very low temperatures, the expansion and compression will be a little greater than that of the solids. As we told, solids can be expanded or contracted very little. But compression and expansion is very less in solids, but in liquids it is a little greater. Liquids have more interparticular spaces and less interparticular attractions when compared to solids. Here also 2 points we are going to discuss. One is interparticular space. This means the space or gap between the molecules of a matter. In the liquids, the gaps between the molecules are a little greater than when compared to liquids. And the force of attraction, the interparticular attraction between the molecules is a little less when compared to that of solids. So this is about the liquids. Next, let us see the third state of matter, that is about gases. In gases, molecules are at a greater distance from one to other compared to solids and liquids. Means here molecules are very free to move out there and here. The attractions between these molecules are less than compared to solids and liquids. So there is no in general words to say, the friendship between the molecules is very less in case of gases, and the friendship is very strong in case of solids. If the friendship is greater, the molecules will be always together. They move wherever they go, all together. But in case of gases, the friendship between the molecules is very less. You can say it is negligible when compared to solids and liquids. So as there is no friendship or attraction between the molecules, they move there and here. If one molecule is here, one more will be here, one more will be there, one more will be outside. In this way, there is no restriction for the molecules in the case of gases. Here we can see some examples given for the gases. These all balloons are filled with the gases, because this they have shown as we cannot see these gases with our naked eye. As gases, most of the gases, they do not have any color to them. Most of the gases are colorless. Of course, there are few, like nitrogen dioxide is one of the gases which is having brown color, reddish brown color. And one more gas we can say chlorine, greenish yellow colored gas it is. Like that, very few gases are there colored, but most of the gases are colorless. Because of this colorlessness only, we are able to see whatever the objects are there in front of us. Because this all atmosphere is filled of gases. If these gases are having any color, we cannot see what is there in front of us also. As these gases are not having any color to them, we are able to see clearly all the objects. Now, let us go to the general properties of these gases. First among them, a gas has neither a fixed shape or nor a fixed volume for it. It assumes the volume and the shape of the container in which it is kept. That means, as there is no restriction for the molecules of a gas, they won't stay at one place. If you take a gas into a container like balloon or a glass vessel, the molecules will occupy entire space available to them. That is why we say gases will take the shape of the container in which they are stored, and even the volume also. But in the case of liquids, we said they have fixed volume, but they take the shape of the container in which they kept. But by coming to the gases, they take the shape of the container, and even the volume of the gas also will be considered as a volume of the particular container in which it is kept. Next property, gases can be compressed to a much larger extent than solids and liquids. Yes, the compression property is very much larger to gases. For this very nice example, we can say the gas cylinders which we use at homes for cooking purpose. LPG cylinder that contains a huge amount of gas which we use nearly months for cooking. The complete gas which is kept in a small cylinder, this much size. If you allow that gas to expand freely at normal atmospheric pressure, that gas can occupy nearly 3-4 apartments in place. Very huge place to occupy. But the same gas is compressed to very small volume. That means the compressibility is maximum in case of gases. And next, a gas expands to a greater extent on being heated. That means the expandability also is very much larger than the solids and liquids for gases. Gases freely mix with one another. This property of gases mixing one into other is called diffusion. This is daily observed in our lives. Suppose if you light in a agarbatti in our puja room, the fragrance of that agarbatti can be immediately absorbed in all the rooms. This is because of this that fumes obtained from that agarbatti are spreading into the air and mixing with other gases existing in the air, and we are able to feel them. The property of mixing of gases in one another is called as diffusion. Gases have very large interparticular spaces and negligible interparticular attraction. There are the two more properties. As I said, the interparticular spaces are very high because there is no boundary for these molecules in the gases. They won't have any attractions between them. That is why they will be very far away from one to other. Then the distance between them will be very high when compared to solids and liquids. That we say interparticular spaces are very high in case of gases. Whereas the interparticular attractions, as there are no attractions, we say completely they are negligible in case of gases. So these are the properties of gases. Next we go with the fourth state of matter, that is called plasma state. The plasma is the fourth state of matter. Plasma is similar to the gaseous state. Of course, it appears like gaseous state, but it is different a little in case of composition. Plasma is made by heating a gas. As we know, when we heat a solid, it converts into liquid state, as we know. If a liquid is heated, it converts into gaseous form. And then if you heat a gas, what happens? That converts into plasma state. But this conversion into plasma state is not done at normal conditions. The temperature should be very high. If a gas is heated to very high temperatures, then that gas converts into plasma state. The plasma state is obtained by the atoms and molecules in the gases loses all the electrons in them and forms ions and as well as electrons to coexist in the matter. Then that state obtained is called plasma state. What happened here? If you heat a gas at too high, very high temperatures, the electrons in the molecules or atoms of these gases will be emptied out. Then there exist ions of the atoms or molecules and electrons. The coexistence of these ions and electrons is known as plasma state. So here is a very familiar example for us which is having plasma in it, that is the sun. The plasma is produced in the sun and stars because of very high temperatures. We know these stars and the sun are composed of some gases like helium. There some nuclear reactions occurs which we study in the higher classes. Because of these nuclear reactions, very huge amount of temperature will be released out. Heat will be produced out. Because of that high temperature and heat, the gases existing in them will be ionized. Ionized in the sense the electrons in those atoms will be emptied out, and hence ions and electrons will be remained in that. That state, that coexistence of these ions with electrons is a plasma state. So we can say sun is a globe of plasma. Not only the sun, remaining stars also in the same way. So because of the presence of this plasma in these stars and sun, they glow when we see them. They appear very glow. So on the earth also, often we observe this existence of plasma, but very rarely. One of them is lightning. In the time of lightning, high voltage of electricity will be produced by the clouds, as we know, because at this very high voltage, the gases in the atmosphere in the fractions of seconds, they will be ionized and they form some plasma state in that. So there we can observe the plasma existence. And even southern lights, there also we observe some plasma. At the evenings in the sky we see some different colored lightning. This is because of plasma existing there in the space. And next, the fifth state of matter, that we say Bose-Einstein Condensate, or BEC commonly called. In 1924, Albert Einstein and Satyendranath Bose together predicted the Bose-Einstein Condensate, which we commonly call as BEC, which is referred to as the fifth state of matter. A Bose-Einstein condensate is a gaseous superfluid phase formed by the atoms cooled to very low temperatures, which is equal to 0 kelvins or absolute zero temperature. So in the fourth state of matter, as we told, when gases are heated to very high temperatures, plasma is formed. When this matter is cooled to very low temperatures, in the quite opposite way, it is nearly absolute zero temperatures, that we say minus 273 degrees Celsius or 0 kelvins. The temperature is called absolute zero. At this temperature, the intermolecular spaces will be almost zero and the vibrations of molecules will be nullified. Then that state obtained is called Bose-Einstein Condensate, that we say as the fifth state of matter. A Bose-Einstein Condensate, or BEC, is a state of matter of a dilute gas or bosons cooled to temperature very close to absolute zero or minus 273 degrees Celsius or 0 kelvins. This is called absolute zero. When a matter or gaseous phase is cooled to this temperature, all the molecules will freeze. There are no interparticular spaces, there are no vibrations between the molecules. Volume of that content or matter will be almost zero. That state is called Bose-Einstein Condensate, or fifth state of matter. Under such conditions, a large fractions of atoms collapse into a lowest quantum state. Lowest quantum state means the matter is the very lowest energy, and at that state that becomes a superfluid. That state we call as BEC. Now we are going to see some questions on this concept. Here we say a question: a few substances are arranged in the increasing order of force of attraction between their particles. Which one of the following represents a correct arrangement? See here, in options they have given different kinds of matter, In the first option, we observe water, air, wind. And the second, they have given air, sugar, and oil. Third option, they have given oxygen, water, and sugar. And last, they have given salt, juice, and air. They are asking to find out the increasing order of force of attractions between these. Means the first matter should have the lower force of attractions and the last one should have greater force of attractions in its molecule between among the molecules of it. If you observe in the first option, water is a liquid. It has some force of attractions. If you see the second one, it is a gas. Air is a gaseous matter. And even wind, it is also a gaseous matter. Here the force of attraction is greater in liquids, so we can show like this. So it is not the increasing order of force of attractions. Next, if we observe the second one, air. Air, as we said, it is a gaseous composition. In gases, molecules are having very less attraction between the molecules. That is, force of attractions are very less. So this is, let us consider, gaseous state. If we see sugar, as you know, sugar crystals are in the solid state. In solids, the attraction between the molecules or force of attractions are very high. And next, if you see oil, oil is a liquid. In the liquids, there are force of attractions between the molecules, but they are somewhat less than that of in case of gases. So we can show like this the arrangement. It is not the correct increasing order. Next, if you see the third one, oxygen. Oxygen is a gas. In this, force of attractions are very less. If we see next one, water. Water is a liquid. In this, there are some force of attractions. And next one, sugar. Sugar is a solid. Now, gases are having less force of attractions than liquids. Liquids are having less force of attraction than solids. So here there is increasing order of force of attractions in the molecules of these three substances. So this will be the correct option for this question. If you see the fourth option also, let us go through. First, they have given here salt, which is a solid, and a juice, which is a liquid, and here the last one, air, which is a gas. If you observe the force of attractions, solids are having greater force of attraction than the liquids. Liquid is having greater force of attraction than gases. So here the force of attraction is in the decreasing order. First one is having greater, last one is having lower. So this will become wrong answer. So finally, correct answer for this question is C. That means gases are having low or least force of attractions, and solids are having greatest force of attractions between their molecules. Next, let us go through one more question here. The property to flow is unique to fluids. Here, the fluids means which can flow. The substances which can flow are known as fluids. Which one of the following statements is correct about this fluid? They are asking. Let us see, first option given here, only gases behave like fluids. Second one, gases and solids behave like fluids. And third one, gases and liquids behave like fluids. And the last option, only liquids are fluids. So what are the fluids? First we have to be clear. Fluids are the matter or the substances which can flow in their own. So the matter in which there are some less attractions between the molecules can move from one to other easily so that they can flow. As we discussed earlier in the discussion of different states of matter, liquids are having some less attractions when compared to solids. So the molecules or liquids can slide one another so that they can flow. Liquids can flow. At the same time, in gases also, between the molecules of gases, the attractions are very less, and the molecules are having much freedom to move there and here. So gases are also fluids. They can flow in any direction, but the liquids have restriction. They can flow from higher altitudes to lower altitudes only. Anyhow, both are liquids. Gases and liquids, both are liquids except solids. So here we can say that is found in third option. gases and liquids behave like fluids. This is the correct option. In remaining all cases, it will be wrong. Next, let us go through one more question on this. In which state are the distances between the particles greatest? Distances between the particles, that means intermolecular distances. The gaps or distances between the molecules of a matter are called intermolecular or interparticular distances, or simply to say the distance between the particles. They are asking which state of matter has greatest distance between its molecules. If you see gas, first option gas, second one given liquid, and third solid. The fourth one they have given both liquids and solids. But as we have studied earlier, the molecules are very free and they have much freedom to move. In case of gases, they have no boundaries to move there and here. And there are no attractions between the molecules. Molecular attractions are very less or negligible in case of gases. That is why the intermolecular distances or distance between the particles are much greater or greatest in case of gases. So A is correct answer for this question. Let us go through one more question here. Which one of the following is a property of gases? So earlier we have seen some properties of gases. Here we see which is correct about the gases. First one given here, they have no rigidity, they can diffuse. Third one, they have definite mass. Fourth option, they have given all of these. First, let us go through this. First option, they have no rigidity. What does it mean, rigidity here? Rigidity means having fixed shape, uncompressibility. But gases are highly compressible. They have no rigidity. They can be easily compressed. We have explained one example, the gas cylinder, which we use in the house for cooking purpose. That contains a huge amount of gas, which can be filled entire home. That is kept in a small cylinder. That is because of the high compressibility of that gas kept in it. That means gases are no more rigid. They are highly compressible. So first option is correct about gases. Next one given here, they can diffuse. As I told, diffusion means the spreading or intermixing of gases one into other. This property is much there for gases. For this also we discussed one property. When you light a agarbatti, if you spray some perfume in one of the corners of the room, that smell of that perfume, that fragrance of the perfume or that agarbatti can be immediately sensed by the persons who are very far away from it. This is because of the spreading of these molecules, of the spreading of this perfume or agarbatti scent molecules in the gases very immediately, very rapidly. This property is called diffusion. So this is very high for gases. So second option is also correct regarding gases. Third one, they have definite mass. Of course, they do not have any fixed volume. They take the volume, they occupy the volume of the container. The volume of the gas is considered as the volume of the container in which it is kept. And even the shape also, they won't have any fixed shape. They take the shape of the container in which they are kept. But gases have fixed mass. Not only gases, three states of matter in common, they have this property, that is a definite mass. Matter will be always having definite mass. Of course, even in the gaseous state also. So even third option is also correct for this. Now, correct option for this will be D, because it is given all of these correct. So in this way, we can go through different states of matter. They are solids, liquids, gases, plasma state, and even Bose-Einstein Condensate. Out of these five, three are frequently seen in everyday life, but the remaining two are a little different for us. So thank you for watching our video. Please subscribe our channel so that you'll be getting always the updates regarding our live classes whenever we're going to teach these all. We'll be getting the schedules regarding these video classes. So if you subscribe once, immediately you'll be getting notifications about this. will be getting some alerts about these videos when you are going to have a particular task, on which subject you are going to have, on which topic you are going to have, so that you can be ready for these classes. And you can press the bell icon for receiving these all latest updates. So thank you guys. Thank you for watching our video.